Okay, so I wanted to record this short video just to explain a difference between two types of radio frames or two frames. One is for frequency division duplexing case and the other one is for time division duplexing case. The radio frame which is used for frequency division duplexing is also termed as frame type 1, and then the one which is used for time division duplexing or TDD, that's termed as frame structure type 2. If you don't know the difference between FDD and TDD, then the short link for the video between the difference between FDD and TDD is given at the end of this video or below the subscription. So right now what you're seeing is the radio frame for FTD, and what this frame has, each radio frame has 10 millisecond in duration, and in this case the downlink and uplink radio frame has two different frequencies. So that's granted. What I wanted to focus in this video is the TDD or time division duplexing radio frame. This is just the structure for FTD radio frame or frame type 1. Whereas when you look at frame structure type 2 or a TDD radio frame, what happens is in this case, in time duration, it still consists of 10 millisecond. However, the interesting thing or the important part here is that in this case, since there is just one unpaired spectrum or one RF carrier, which carries both uplink and downlink information. So in this case, all the subframes are the same, but then there is always at subframe number 2 and subframe number 6, there are switching subframes. And when I'm saying switching subframes, meaning here the switch takes place, either the information should come from downlink to uplink or uplink to downlink. So the special subframe is one of the difference between a TDD radio frame and FDD radio frame. And what is this switching subframe, or what a TDD radio frame as a whole looks like? As I mentioned, that in this case there are different subframes which are carrying only downlink information, and some subframes are carrying only uplink information. So if you see in this particular diagram, there are 7 different flavors or 7 different configurations of frame structure type 2 or TDD radio frames, and each of this configuration depends on how many subframes are carrying downlink information and how many are carrying uplink information, while subframe number 2 and subframe number 6 are only switching subframes. So at the last column or the third column where it says downlink uplink ratio, that ratio is computed based on number of downlink subframes and uplink subframes, which is shown over there. So that's the difference, main difference. There are 7 different configurations between for a TDD radio frames, and each of the specific special subframes. Another important difference which you need to understand is the special subframes which are at subframe 2 and subframe 6. Those switching subframes have a structure like this. This slide. So the switching subframe is expanded at the bottom, and in switching subframe there is a portion for downlink which you see, and then there is a guard period and uplink. So why there is a guard period and why there is a downlink portion, uplink portion, that's another discussion. But then the point I am trying to make in this short video is that the structure in terms of time domain is both FDD and TDD radio frame consists of 10 millisecond. However, the difference is in terms of the way the subframes, the kind of information they are carrying. Some subframes are carrying downlink information, some are carrying uplink information, and based on that the throughput calculations in TDD is different than FDD scenario. For example, in special subframe, how many OFDM symbols will be there? You can see over here, there are in one subframes using normal cyclic prefix, there are 14 OFDM symbols, and how many of OFDM symbols are carrying downlink information or how many of them are carrying uplink information, that also can be configured. So the special subframe also has different configurations of special subframes, and that configuration depends on how many OFDM symbols are there carrying downlink or uplink information. So the point of summarizing all this information is that you should understand the difference between TDD and FDD radio frame. So far we discussed some of the differences in TDD radio frame, and based on those differences, the calculations for the throughput computations are different. For the case of time division duplexing, there are actually a little bit less throughput because of these differences in the time division duplexing or TDD radio frame and the way the subframes are arranged and OFDM symbols are arranged in special subframes. That's why those differences are always, or deviation in throughput always comes in.